Recording in progress.
Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics, unit number 8, electrical current. Series number 3 is going to be discussed. Earlier, we completed what is meant by electrical current and how it will be performed in the activity, how we can glow the current by using battery and connected with the electrical conductor and optimized with the switch. So that kind of activity was performed. Now we entered into series number 3. In addition to this one, earlier we completed unit number 1 to 8, the entire detailed explanation available on the channel called World of Competitive Chemistry. Now let us enter into the series number 3 of this electrical current unit number 9. Here, the motion of electron is shown in the figure 3. So how the electrons are moving, the motion of electron is simply called as electrical current. Okay, so this is known as a drift velocity. We are going to discuss about a new term called the drift velocity. Here, when electrons are flowing, direction of electrical field, motion of electron is described in this. Now, we assume that electrons in the conductor move with the constant average speed. Some are colliding with the walls of that conducting material, and in between the electrons also collisions are possible. So in accordance with the average speed, we are not going to consider the individual speed of electrons, rather average speed of electrons will be taken into the consideration. We call this speed as a drift speed or a drift velocity. A constant average speed which assigned to the electrons flowing through the conducting material is denoted as a drift speed, which alternatively known as drift velocity. Now let us give the perfect definition for this drift velocity. Drift velocity can be defined as the velocity or speed which acquired by the electrons inside the conductor when it is subjected to the external electric field. Under the influence of external electric field, how the electrons are moving inside with the constant velocity under the influence of electric field is denoted as a drift velocity. Let E will be the electric field and which applied in the conducting material. Then force F, force is denoted with F. F is equal to minus E into capital E. E denotes the electrical field, E denotes the charge present on the electrons. This will be the numerical description of this drift velocity. Let us repeat one more time. The constant average speed which are assigned to the electrons flowing through the conducting material under the influence of electric field is denoted as a drift velocity. So in an average, all electrons are moving with the constant speed. Now, let us calculate the drift speed of the free charge quantitatively. So, free charge when taken, so its drift speed is going to be calculated now. Consider a conducting material and which is bisected with the cross-sectional area A. Here the cross-sectional area is mentioned, which is denoted with A. Assume that ends of the conductor are connected with the battery. When it is connected with the battery, then only directional flow of electrons are possible and they are moving in the regular manner. Otherwise, random arrangement is possible in the open circuit and that will not cause any kind of electrical charge. That's the reason why both the ends of this conducting material should be connected with the battery. Battery is the source of energy through which high potential to low potential passage of electrons are possible in the regular ordered manner, right? So here, through the battery, current flow is possible. Let Vd is considered as the speed of the drift, right? Drift velocity, which is also denoted as drift speed of the charges as shown in the figure. Here, we are taking the conducting material and here hypothetical material was inserted, which is called a cross-sectional area denoted with the A. Now, these two ends are connected with the battery so that electrons are moving in this direction. So these electrons are moving with the constant speed called Vd. Vd is denoted as a drift speed. And N will be the number of charges present in the conductor. Number of charges denotes what? Number of electrons present in the given conducting material, which is taken as a unit volume. So in the particular unit volume, how extent of charges are moving, that is given as N, right? So which simply called a charge density. N is denoted as charge density. Now A will be the cross section area, and a drift of positive charges were taken in this picture. Number 4. Now, the distance covered by each charge in the 1 second is denoted as VD. So, how extent they are traveling? So, within 1 second, the distance covered by the electron, individual charges, that is denoted by VD, drift speed. Then, volume of the conductor for this distance is given by AVD. A denotes area of cross section. VD is nothing but drift velocity. The product of these two is considered as a volume of the conductor in this particular distance, that is denoted as AVD. So here it is a product of cross section with the drift velocity that is mentioned in this figure number 4. The number of charges contained that volume is equal to NAVD. N denotes what? Charge density. AVD is nothing but volume of the conducting material. Now, the collection of all these is called the number of charges contained in that volume. How many charges containing in that volume, that is given by the NAVD. Let Q will be the charge of each carrier. Each electron is carrying certain extent of charge, that is denoted with Q, right? Then the total charge crossing the cross-sectional area at a position D in the second is given by NQAVD. N denotes what? Charge density. Q is the charge carried by the individual electron, and A is the area of cross section. VD is nothing but drift velocity, right? So here what we are discussing, total charge crossing the cross-sectional area at the position D in a 1 second is given by NQAVD. This is equal to electrical current. The product of all these numerators exactly is equal to electrical current, right? So this is the formula which is provided for this drift velocity. This is called a quantitative calculation of this electrical current. Now, the equation is mentioned in this manner. Electrical current is given by I is equal to NQAVD. Let us define individual terms. VD means what? Drift velocity. And I for current flow. How extent current is flowing. N means free electron density, which is simply called as charge density as well. E is equal to charge of the electron. Individual charge of the electron is assigned with E, and A is nothing but cross-sectional area. Now, equation can be written if we want to determine drift velocity or drift speed of the given electrons present in the conductor. VD is equal to I by NQA. So this is an alternative representation of this formula. So quantitative determination is possible if we apply all the known parameters in this equation. We know that charge carriers in the conductor are electrons. Obviously, conductor is a flowing current from one region to another because of flow of electrons. The magnitude of electrical charge E is given by 1.602 into 10 to the power minus 19 coulombs. Right? So here electrical charge, this will be the constant parameter. Its magnitude will be assigned as 1.602 into 10 to the power minus 19 coulombs. That is provided in this diagram. Let us assume this is the electrical current. So where electrons are flowing, being all electrons in the conductor are freely available, so that movement of electrons are spontaneous in nature. So each electron is carried with the charge 1.602 into 10 to the power minus 19 coulombs. Now, let us calculate the drift speed of the electron in the copper wire. We are using copper wire most oftenly for the conduction of current from one region to another, carrying the current in 1 ampere, and the cross-sectional area A is equal to 10 to the power minus 6 meters square. The electron density of the copper was found experimentally. N is equal to 8.5 into 10 to the power 28. So all these parameters are well known to us. So it's very obvious to determine its a drift speed, because we have the drift speed formula also. Drift speed formula VD is equal to I by NQA. Here I is known, N is known, Q is known, and A is also known to us. So if all the parameters are well known, substituting all these values in the equation number 2, just now we saw that equation, Q is equal to E. Then we will get Vd is equal to here electrical current I is equal to 1 ampere. That's the reason why we are substituting I is equal to 1. And N value is 8.5 into 10 to the power 8, 10 to the power 28 into what we are taking. The next term will be Q. Q is equal to what they assigned. Q is equal to E. E is nothing but electrical charge, that is given by 1.602 into 10 to the power minus 19. That parameter was taken here, right? So after that, A, area of cross section, that is given by 10 to the power minus 6. 10 to the power minus 6 also taken. All the parameters are substituted in this equation, drift speed equation. Now, Vd is equal to, after calculating, it will be simplified into 0.07 mm per second, millimeters per second. So this will be the drift speed if all the parameters are well known to us. So that is the case where we are taking copper wire as an electrical conductor, and 1 ampere of the current is able to flow through that, and the cross-sectional area is denoted as 10 to the power minus 6, and the density of electron is given by, electron density is given by N is equal to 8.5 into 10 to the power 28, and electron charge is given by 1.602 into 10 to the power minus 19 coulombs. In that case, drift velocity is given by 0.07 millimeters per second. This shows that electrons are moving very slowly. Movement of electrons are not much fast. Now we have a question time. Why does the bulb glow immediately when we switch on? So whatever the distance it may be, even after 1 kilometer distance, if we are switching on here, immediate bulb glowing or illumination is possible. What could be the reason for that one? I collected this answer from .NET. Thank you very much. When we switch on any electrical circuit, irrespective of its length of the conductor, an electrical field is set up throughout the conductor instantaneously due to the voltage of the source connected to the circuit. This electrical makes all the electrons to move in the specified direction simultaneously. Hence, a bulb will glow. What happens? It need not to take the electrons from the source and send them to the target destination what we are expecting. So just what happens when we are switching on electrical circuit to get activated, so that simultaneous movement of electrons are possible because of voltage imbalance. In order to make the equivalence of voltage, what happens? Electrons will be moving in the stipulated time, so that illumination of bulb is possible spontaneously, and even within fraction of seconds bulb glow is possible, irrespective of the length of source to destination point. So that's the reason why immediate glow of bulb is possible when we are switching on the light. Why does the bulb glow immediately when we switch on? In continuation to this question, when we switch on any electrical circuit, irrespective of the length connected with the wire, an electrical field is set up throughout the conductor. So new electric field gets generated in the conducting material. Instantaneous generation is possible due to the potential difference. Some region where the destination point is there we are experiencing low potential. Where the source is there, here the high potential will be there. In order to maintain the balance between these two, electrons will flow immediately in order to balance that charge efficiency. That's the reason why potential difference is the main cause of this electron flow, and that used to illuminate the bulb within the fraction of seconds. This electrical field makes all the electrons to move in the specified direction simultaneously. Whenever battery is connected with the conducting material, electrical field get generated, that get activated, potential difference will be originated. That difference is the main cause in order to illuminate the bulb in the spontaneous manner. Immediate glow of bulb is possible. That's the reason why while switching on, so at the moment of switching, that time only glowing of bulb is possible. How can we decide the direction of electrical current? Whether it is moving in right hand side, left hand side, what could be the direction of electrical current movement? How can we predict? So for that purpose, we have the detailed explanation here. The direction of electrical current is by the convention, by the direction which positive charge would move. How the moment of positive charge is there, in that direction electron flow will be there, because always electrons are moving towards the positive end, because always opposite charges having the moment in that direction only, electrons having movement in this direction. And does the current in the external circuit, when we go with the external circuit, that will be in the opposite direction. Flow of electrons in the manner of positive end direction, and electrical current, external electric current is moving in the opposite direction, because in order to minimize the repulsive forces between the electrical current and the internal electrons, the moment will be in the opposite direction. Okay, electrons are moving towards the positive end, electrical current is moving in the opposite direction. So this is the case where you can observe the direction of electrical current movement. Electrons would actually move through the wire in the opposite direction. Electrons if moving in left hand side, electrical current is moving in right hand side. Obviously they are used to make the complete circuit so that illumination of bulb is possible. And in the equation, we just saw how the equation got derived in order to make the quantitative assessment of drift velocity. We got I is equal to NQAVD. I denotes what electrical current that measured in amperes. N is the charge density. Q is given as E. Here Q is given as E, which is called electrical charge. And A is nothing but area of cross section. VD is nothing but drift velocity. So this is the finalized equation in order to measure the quantitative parameter of this drift velocity. This indicates that the values of N and A are positive in nature. Always this charge density and area of cross section values are positive in nature. The direction of electrical current is determined by the sign of charge Q and the drift speed of VD. And always these values will not be varied. That's the reason why the variables are two. One is a Q, charge density, charge electrical charge denoted with Q, and the drift speed denoted with VD. These are the deciding factors in order to measure the electrical current. Right? For electrons, always electrons are carrying negative charge. Q is a negative always, and VD will be positive. Then the product of Q and VD will be negative. The final product of Q and VD will be negative in nature. This negative sign shows that direction of electrical current opposite with respect to the negative charge. They are assigned with the negative charge. That's the reason why with respect to opposite. So here negative charge is there. Opposite to negative charge, they are moving towards the positive end. For the positive charges, the product of Q and VD will be positive. In that case, direction of electrical current be taken as the direction of flow of positive charges. So that depends upon the product of this VD and Q. If VD and Q product is negative, this electron flow is possibly away from this negative charge. If the product of VD and Q is positive, so they are moving in the direction of positive charge. That depends upon the product of Q and VD. So if its product is negative, away from the negative. If its product is positive, towards the positive. So this is the case where you can observe the direction of electrical current with respect to this equation. Now, how can we measure the electrical current? What is the instrument or device used to detect or predict this electrical current? Current can be measured using an ammeter. Ammeter is a device which used to measure the electrical current. The strength of electrical current is measured with this one in amperes. Electrical current can be directly measured with the galvanometer, but this method involves the breaking of electrical circuit, which is sometimes inconvenient to us. Current can also be measured without breaking the circuit by detecting the magnetic field associated with the current. Always electrical current and electrical vector and magnetic vector, always they are associated. Even in the electromagnetic radiation, you can observe both are oscillating in the perpendicular manner. That's the reason why here two conditions are there in order to measure the electrical current. Direct measurement of electrical current is possible. or else your magnetic vector of this electrical current is also measured. With respect to that, we can indirectly measure this electrical current as well. Because in order to measure the electrical current directly, first we have to break that electrical circuit. Circuit is nothing but a complete cycle. That cycle should be cleared, then only it is possible to measure electrical current by using the device called ammeter. Right? How do you measure the electrical current? Electrical current measured using ammeter, more commonly digital multimeter. In order to properly measure the current, all the current must flow in the meter and back out again. Then only circuit will be generated, that will be tested, and the current strength will be assigned to us. So in two ways, it is possible to measure the electrical current. One is direct measurement of electrical current by using the electronic device called ammeter. Or else, if we are measuring in terms of potential, that is the device called a galvanometer can be employed here. And a second category where you can measure its magnetic strength. Always magnetic strength is exponential property of this electrical current, so that always both are associated. So indirect way also electrical current strength can be measured. How can we measure the electrical current? Usually, ammeter is used to measure the electrical current. It is always connected in a series to the circuit. So series is nothing but one by one arrangement is there. So parallel manner is different and series manner is different. Series will give the product of all the individual current. So in this manner, ammeter used to measure the electrical current strength in terms of amperes. Now, where do the electrons get energy for their motion from? How the electrons are oscillating, how always they are having spontaneous motion, from which they are getting energy. Let us discuss. The electrons are constantly interacting with the nucleus via the virtual particles called the photons. Photons are the external source of energy packets. And opposite electric charge of the nucleus creates the force that attracts the electrons towards the nucleus. Right? Here, virtual particles called photons used to give the energy to this one. Here it is clearly depicted in this diagram. This is the kind of process where electrons are used to emit the energy, and they are used to absorb the virtual protons. So here the concept of photons given by Einstein scientist, and these photons used to energize these electrons, and where continuous movement of electrons are possible. Right? So they're constantly interacting with the nucleus where protons are there, and even neutrons also present. And while bombarding with that one, photons are getting their energy, so that electrons are continuously oscillating. Photons are the major source for the energy of electrons. The concept of photons given by the scientist called Einstein. By this, we completed this session number 3 of unit number 8, unit number 9, electrical current. I hope this session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you, one and all.